Hey everyone! In today's video, we are going to learn how to solve a z-score from a sample. And we're going to play make-believe for a moment. So pretend that your class has just competed to see how many push-ups each of you could do in 60 seconds without having a rest. The actual experiment doesn't matter, but we need some data. After finishing, you calculated your mean and standard deviation, and now you have been asked to solve some z-scores. I'm actually going to give you the mean for the class. Say our little sample mean is 22, and we're going to say that our standard deviation is 14. And in some previous videos, we looked how to calculate those, but we're going to save some time and not go through all the raw data here today. What I want you to do first is solve the z-score of someone who did 30 push-ups. So the class average is 22, a standard deviation of 14, and we want to know what the z-score is of someone who did 30 push-ups. Keeping in mind that your z-score is a measure of how far away you are from the mean in standard deviations. So we have an equation for this, and it is z equals x subtract x bar all over s. I do want to point out, sometimes you'll see an alternate version of this equation where it's z is equal to x subtract mu all over little sigma. They do the exact same thing as far as calculations go. However, one of them, the one that we're using, is for a sample, like in your class. This z-score is used if you have the entire population information. So everyone did a push-up, then you would use this calculation. Incidentally, it's the exact same calculation, except it's sample mean versus population mean, and sample standard deviation versus population standard deviation. And just so that you know, in case this ever shows up, the calculation is the same. So we're going to go ahead and fill in what we know. Z equals x. X is our data point. It's personal. It's how you did in push-ups. In this case, 30. We need to subtract x bar, that's the class mean, which is 22, and divide it all by our class's sample standard deviation, 14. This tidies up really nice and really fast to give us z equals 8 over 14. Z equals 0.57. What this means is that a person that did 30 push-ups is 0.57 standard deviations above the class average. Which, let's face it, if you're between -1 and 1, you're pretty well average. You might be a little better than average, but you're pretty well average. You're in that big, beefy part of the bell curve. Let's go ahead and do another example. This time, we're going to look at someone who did no push-ups. And this happens every time we do this experiment, and it's actually surprising results because there's usually a whole bunch of people that are just like, I'm not doing any push-ups at all. You can all do push-ups. You just got to put your mind to it. You can do this. I believe in you. But let's figure out what their z-score was. So again, we're going to hit up our equation, z equals x subtract x bar all over the standard deviation. This time, if someone did no push-ups, their x, which is their value, is 0. We still subtract the class average, 22, all over our sample standard deviation, 14. Knock this out. Someone's going to get a z-score equal to -0.157. That means they were about -1.5 standard deviations away from the average, which is still fairly normal. It's not below -2. It means it's pretty usual for someone to do 0 push-ups. This data is actually good data. We did this in our own little experiment. So if someone did 0 push-ups, they would have a z-score of -1.57. I want to do one last little example here. So this was a question that came up last time I did this little lab activity, and it's a great question. What if someone wanted a z-score of 3? So now we're looking at someone who is exceptionally good at push-ups. So if our class average was 22, and our class standard deviation was 14, and someone wanted to be recognized as being truly exceptional at push-ups by having a z-score of 3, how many would they have to do? Well, again, we look at our equation, which is z equals x minus x bar all over our standard deviation. We set our z value equal to 3 equals, we're going to be solving for x this time because we want to know how many push-ups we'd have to do, minus the class average, which was 22, all over our class standard deviation of 14. We multiply both sides by 14, and we get 42 equals x. Subtract 22, add this 22 to both sides, and you will get x equals 64. So that means in this class that has a class average of push-ups of 22 and a standard deviation of 14, if you wanted a z-score of 3, which means a truly exceptional push-up doer, sure, you would need to do 64 push-ups. I hope that this was helpful. This is how you can solve z-score from a sample and a few ways that you can go backwards. If you have any questions, please feel free to leave them in the comments below. Thank you very much.